We're going to finish our talk about the law of sines, picking up with the side-side angle situation, and we'll finish everything off. So let's start with an example, or SSA, that we know that the measure of angle A is 20 degrees. Measure of side A is 10, and side B is 15. So let's go ahead and draw a triangle to represent this. And we'll try to make it as accurate as possible. There's our 20 degrees. That's 10. That's 15. There's C, there's B, there's side C. All right. So in order to do this, we need to find angle B first. And what I like to do is make a chart just to keep everything organized whenever I'm doing these. Make sure that I don't miss anything. Then keep my numbers straight. All right, so there's what we got. So we got to find angle B. So here's a change from what we did before, that we want to use the equation that has sine of B over B, and then the sine of A over A. So we're looking for an angle, so we want the angles on top. And we can do what we did before, just multiplying our B over. So our sine of B is going to give us, let's see, 10, or excuse me, 15 sine of 20 over 10. Make sure you are in degree mode and be careful with your parentheses. And it turns out that this is a very small number, that it's 0.5130214989. All right, but be careful. That is not your angle B. That is sine of angle B. In order to find angle B, the measure of angle B, we need to do an arc sine of this. So it's also important that you do not round. If you round, you can have a big enough error that it will make a difference, especially when you're doing arc trig functions. That small changes in your number for the input can make big differences in your output. So what this turns out to give us is 30.865882471 degrees. All right, so now we have to find our angle C. Since we already know angle A and angle B, we just add them together, subtract from 180. So this will give us 13411.75269 degrees. And then finding side C, we'll go back to what we did before. And let's use side A and angle A because those were given to us. So we're going to get 10 sine of 30, excuse me, 129.1341175,269 divided by sine of 20. And side C is 22.679,094,7967, and whatever units we're doing. All right, doing our quick check. Side A is the smallest, so is angle A. Side C is the biggest, so is angle C. So angle C, side C, both biggest. All right, everything matches. However, there's one little issue. Going back to our triangle, if you would try to draw a triangle with these dimensions that we're given over here, this will not necessarily be what the triangle looks like. So our side A could be over here. So this side, it could swing back and forth, and it matches up in two different spots. So that could be our 10, meaning our triangle looks something like this. There's B, there's A, there's C. All right, so we don't know which one our triangle is going to look like. And now we have to find the possibility of what happens with this second triangle. Now notice that this triangle here that we made with our 10s, it's isosceles because we both side lengths are 10. And so this angle is going to be the same as that angle. Now this extra angle over here, which is going to be our angle that we're looking for, our new angle B, is supplementary with the other option for angle B. So here we could have two different triangles. Now our angle A is not changing. It's going to be 20. Side A and side B are also set in stone because we were told those. But now with angle B, it could be this 30 degrees, but it could also be its supplement. So we must subtract it from 180. So we're gonna get 149 point. Now it's neat that our decimals are gonna be the ones right here. And now if we add our A with our new B value, we are going to get, was it 169? So angle C could be 10.8658824731 degrees. Now, if we try to find side C, we're going to use the exact same equation we used before, but now different numbers. So getting rid of our big angle for C and putting in our small angle for C, we get 5.51168382693. All right, so we have, and if you look up here, that our side C, oops, in the original one, side C was the longest. Now it's the shortest. Side A was the shortest in the first one. Now it's the middle angle for here. And side B is the longest in our new triangle. And so is angle B is also our biggest. So we have two different situations that we need to account for. With side-side angle, it is called the ambiguous case. Let me rewrite that so it looks a little better. Ambiguous. So what's ambiguous mean? I don't know. Okay, yeah, I do know, but it means I don't know. It's unclear. We're uncertain. We don't know what our result is or what we're going to do. So with side-side angle, you might have a situation with one triangle, but you might have two. So we're not quite sure. So let's try another example. Let's say the measure of angle A is 70 degrees. Side A is 5, and side B is 15. All right, so once again, we're going to find our side, or excuse me, our angle B next. So sine of B over B equals sine of A over A. If we solve for our sine of B, it's 15 sine of 75 over 5. And our result is again, be careful with parentheses. Oops, sorry, not 70 or not 75. It should just be 70. Be careful with parentheses and make sure you are in degree mode. And we get 2.81907786236. Now remember, that's not our angle. We have to do an arc sine. But when we do an arc sine, we get a domain error. Why does that happen? Remember, sine can only be at between -1 and 1 whenever you're done with it. This is all the way up almost 3. So this is impossible to do. And if we would draw this triangle to scale, what's going to happen is this going to look something like this. That our side A is too short. It does not connect to that base. So here, there are no triangles that can result from this information. So this adds to another thing of why our SSA, side-side angle, is the ambiguous case. Not only can we have one triangle or two triangles, in this case, we have no triangles. So 0, 1, or 2 triangles is what we can have. All right, let's do one more example. Let's say the measure of angle A is 50 degrees. Side A is 15, and side B equals 10. All right, drawing our picture. And there's our 50 degrees. All right, let's make our chart to keep things organized. And let's write down our information for our first triangle. And then let's check to see if we could have a second triangle. All right, so first thing we're going to find is angle B. So let's plug in some numbers. Remember, we're going to do the arc sine of this whenever we're done. So it's 10 sine of 50 divided by 15. Doing the arc sine again, make sure you are in degree mode. And our angle is 30.7 1, 0, 2, 2, 0, 7, 6, 6, 1 degrees. For our second triangle, we'll need the supplement to this. So subtract this from 180. And we're going to get 149.289,779,2339 degrees. All right, so let's go start with our triangle 1. Let's finish that off. These add up to about 80. So angle C is going to be slightly under 100. It'll be 99.289,779,2339 degrees. Let's go ahead and find side C. And again, using the information we were given as much as possible so we don't have to rely on a calculation. All right, so it is going to be 15 sine of, remember we got for C, divided by sine of 50. And it turns out that side C is 19.3242938598 units. My nine's looking good, nicer. There we go. All right. Now, if we're going to work on our second triangle, notice something weird. Our angle A and B add up to almost 200 degrees already. So that's over 180. So there's no possible way to make a second triangle in this case. Now, why does that happen? Back here, notice what would happen if we tried to do what we did before of swinging our side A around. In order for it to fit, our triangle looks like this. But we know angle A has to be 50. So we can't make it go inside out like this. So there's only one way to draw it. Now notice here's a nice relationship here between our side A and B. When you have a situation where it's side, little side, angle, you are guaranteed one triangle. So the side with your angle side combination that match up, if that side length is bigger than the other side, so it's big side, little side, then angle in that order, you're guaranteed only one triangle. So that's a nice little thing to check. So it can save you the extra step of even looking for a second triangle. Now, if it's the little side that's over here, and then the big side that's here, you might have none, you might have one, you might have two. Depending on how the numbers work out, it just all depends on how things work, how things go. But here's a nice thing to look for. Now, why is that true? Why does this happen? So back here, with our initial one where we had our two triangles. Now notice something here, and this is a little kind of a flaw, if you want to think of that with our law of sines, is that if you would take both of our angles of B, and if you would do the sine of 30.86 in the rest and the sine of the 149.13 in the rest, you're going to get the same result. So we used an arc sine here, but arc sine only gives acute angles, either positive or negative. It never gives you the obtuse angle. So we never know, whenever we do a law of sines with an arc sine in there, if it wanted the acute or the obtuse. Now in this case, A is not the biggest side. B might be. In our triangles here, B was the biggest side in triangle 2, but not in triangle 1. So that's where the issue falls. We're not sure if angle B is the biggest or not. And therefore, we don't know if it's going to be acute or obtuse. Down here, though, angle B is definitely not the biggest side or biggest side, or excuse me, side B is not the biggest side, so angle B can't be the biggest angle. So therefore, it has to be acute. So we know there's only one. So we have nice interplay here with our ideas of our arc functions and how our sines relate for supplementary angles. And so there's a whole lot of interplay in here. With all of that, it's going to make an impact or have an impact on what's going on with our side-side angle setup. So remember that whenever you're dealing with side-side angle, you might have none, you might have one, you might have two triangles. So that's why it's the ambiguous case. We're not quite sure. But if it's a big side, little side angle, guaranteed just one triangle.